Today we're going to be talking about the final part of the hydrosphere. What is ocean acidification? Please make sure you have your packet out so you can follow along as we go through. So when we're talking about ocean acidification, it all goes back to carbon and carbon dioxide. Carbon dioxide is present in the atmosphere. It's the air we breathe out. The ocean has this incredible ability to absorb carbon dioxide from the atmosphere. It tries to keep everything in balance, which would normally be okay. But humans get involved. As we burn fossil fuels, we release excess carbon dioxide into the atmosphere, which means our oceans are starting to absorb extra carbon dioxide. As we put more carbon dioxide into the oceans, there's a greater potential to harm marine organisms and the delicate ecosystems. To get us started, we're going to watch a brief TED Talk video looking at why the ocean is considered a carbon sink. Please follow along on your worksheet and answer the questions as you hear the answers.
Filling up our atmosphere with carbon dioxide. As a result, the planet's warming. Heat waves and floods are more likely to be extreme, and people's lives will get tougher. And the more we learn about climate change, the more risks we uncover. Since we started burning fossil fuels, the ocean has absorbed about half of all the CO2 we humans have put out.
I want to pause real quick and just point out for you, these green dots that you're looking at are not any poison or anything else in the traditional sense. The green dots are to show you the carbon dioxide that's being burned as we burn our fossil fuels, so you can get a visual of what's happening.
That's why it's called the planet's biggest carbon sink. Now this is good because it's kept a lot of CO2 out of the atmosphere. But as the ocean warms, it takes up less and less CO2. And with all that CO2 in the sea, scientists are shedding light on, well, an ocean of problems. Ready for the first big problem? Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, you've got bigger problems than easy-to-crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood, or if you understand how unstable the world would be with 1 billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat. Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need. They also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve. That means if we don't turn this problem around, your great-grandkids might think of reefs the way you think of a dodo bird. And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But why panic, right? Life always seems to find a way to adapt, but it needs time. In a few decades, we might make the oceans more acidic than they've been in 20 million years. It's hard to imagine any ecosystem quickly adapting to that big of a change. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source, carbon dioxide from burning fossil fuels. Learn more at acespace.org.
So what did we learn? Carbon dioxide gas is released into the atmosphere by burning fossil fuels. It then gets absorbed into the ocean. So we start with our atmospheric CO2, it moves down and gets dissolved into the oceans. It then combines with the water and releases hydrogen ions. As this increases, there's less of these carbonate ions available. Let's look at what that means. Here's our carbon dioxide combining with our water, and it's producing, right here, carbonic acid. We don't have to worry about that too much, but what you need to know is that it's putting these extra hydrogen ions into the water. When that happens, it will combine and take away those carbonate ions that the shells are needed to be able to grow. Let's think back to the pH and the gizmo that you did on Friday. The lower the pH, the more acidic something will become. Down here. If it's more acidic, there is more hydrogen ions. Ocean water is currently right here at an 8. As we continue to add carbon dioxide, we're adding more hydrogen ions and becoming more acidic. So how does this work? What does it do to marine organisms? That carbonate that's usually in the water is used, like this little marine snail, to help build their shells, or the exoskeletons of a lot of other organisms, including our corals. So if they don't have access to that carbonate because it's been stolen by the hydrogen, it can't build as strong of a shell or as big of a coral reef as it would want to. If we don't have these small-shelled organisms because they no longer have the shells to protect them, all of those species that eat those organisms are going to start to lose their food source. Some of the other impacts that we see on our larger communities. So look at the first picture. We can see a nice, happy environment, what we'd want to see in our coral reefs. Don't forget, this is our neritic zone. As we start to build carbon dioxide, it becomes more acidic. Our coral reefs start to die off. As this happens, the algae can start to grow on the reefs. Algae becomes more abundant. There's less space for the animals, and other animals start to die off. And that beautiful rainforest in the sea starts to go away. That's ocean acidification in a nutshell. What you're going to do now is put everything together from this unit in one final project, called our Ocean's Most Wanted project. In this project, you are going to be researching the marine animal of your choice, and then creating a sway to tell us about that. It's okay if you've never used sway before. You're going to follow a template, plug in all the information as you go, and you'll be finished with this beautiful project. This will count as your assessment for this section on marine life zones and ocean acidification. The final project will be worth 30 points, and it is due on Tuesday, February 13th. Let's take a look at your sway. Today, when you get to the computers, you're going to open your email, and it will take you to a link for this project. You'll click on the 3 dots and come down to where it says duplicate this sway, and then you'll need to name it. First initial, dot last name, Ocean's Most Wanted, following the template on your page. Then as you do your research, you simply go through and plug in the information for each section. So here's section 1, your species and its unique characteristics. I've already given you a heading. You're going to select a picture to add in, and then just click on the text cards to add the information as it goes through. The breakdown of everything you need for your project is listed on your worksheet, so you can follow right along with that. Add it in your sway as you go. You will have the rest of class today, all of class tomorrow, and half of class on Monday. Be prepared to work on your own pace. You may choose any marine organism you want, Just follow along with the worksheet. Thanks. Have fun.